Thank you very much, Cloris. Nice to meet everyone, and I appreciate everyone taking the time on a Saturday to talk about PubNub and to talk about, more importantly, what's going on with well, this massive shift that's happening with respect to everyone getting online in massive numbers, obviously because of lots of things, but especially over the last 6 and 7 months because of COVID. Um, and actually, while this is not a talk specifically about machine learning, it does speak to a massive corpus of data that we're creating as not just PubNub, but the world is creating as billions of people spend more and more of their time online, and what they do and the information they create is measured in massive sizes of data that really has never been seen before. So I'll talk a bit about that and some of the things we're doing, but I'm generally going to talk about what the remote world means and what remote experiences mean. So I'll jump right in here. Um, First of all, there has been this huge shift online. I'll just cover a few examples, but I'm sure everyone is aware of this now because we're living it. You can jump into any number of categories from e-commerce, where IBM and others are saying we've just shifted e-commerce by 5 years. And if you don't believe that, take a look at the value of Shopify, which provides a white label experience for e-commerce stores. And I think the company is now worth over $140 billion. So Shopify, small startup, boom, 140 billion. E-commerce has definitely been accelerated dramatically since COVID hit. But it's not just there. We know that in China, when COVID first hit, the number of people going to telehealth expanded by 1,000%. And the same thing happened a few months later here in the United States and all over the world. These were people who never would have actually gone online before to talk to a doctor. Not surprisingly, gaming sales and game usage has driven up dramatically. And of course, workplaces. In fact, people are now working remotely, and this is not going away. I mean, definitely things will decline after COVID, but overall, once people shift these new experiences and these new ways of doing things, um, there's so many studies to show that once you adopt something, especially something that's better, like a telehealth appointment, you're not going to go back to the old experience. A couple other examples, ones that are maybe more corner cases, but driving, again, tens of billions of dollars in value. Digital fitness. So think about the Peloton experience. If anyone knows what a Peloton is, you get on a virtual bicycle, a real bicycle that you're riding, and you have a virtual experience with other people you're exercising with, and the instructor can see quantitative data about how you're exercising and really speak to you directly about going faster or standing up on the pedals and other things. And so while we've seen a huge surge in digital fitness led by Peloton, but others, that's also driving a shift that's going to stay because that experience in many ways is just simply better than what you could do in the real world. And then finally, e-learning, right? So we know that over 1 billion children in the last 6 months have moved to an e-learning environment. And while I think any of us with children are going to be very happy when those go back to the classroom, it is still a lot of the tools that are being used will be brought back into the classroom with the teachers. So I think there's a lot of things that are happening very quickly because of what's happened. So that's just a place to start. But let's just drive in here. So, I mean, what's the good news, right? I mean, the good news is that we're able to do these things, right? Timing is everything. Actually, this number is the year's off. It's actually 2019 when 4.2 billion people were estimated to have been online with us owning a smartphone with high-speed, affordable connectivity. That's more than half the world's population. And can you imagine what the world would have been like if COVID had expanded and exploded as a pandemic just 10 years ago, without most people's access to high-speed data, devices that were affordable to take use of things, cheaper video conferencing to do these kinds of things. So that we're actually very fortunate, I think, as a global society for being where we are at this time. And it's not just our ability to get online, it's also the devices themselves. So this is some data that shows the cost of a little chip that combines both the lightweight processing for business logic as well as connectivity through either Wi-Fi or 3G, 4G connectivity. I guess now some of them are 5G. And so just going back 6 years ago, it cost about $20 for that little component. And now we're in a place where it's dramatically under $1. So you can build devices that are connected online, a system on a chip that can actually bring IoT devices that we can control and monitor things remotely. Again, had COVID hit just 10 years ago, it would have been a very, very different world with respect to monitoring things remotely without physically being out there, controlling things remotely as well. So in a lot of respects, we're really, really fortunate that this happened now and not just a few years prior. Okay, moving on. This is something that PubNub's been thinking about for a long time, actually. I started this company with my co-founder 10 years ago. And even back then, we established PubNub with one clear vision. And that was to establish experiences online that were at least as good or better than the ones in the real world. Now, that's a pretty big vision. There's lots of things we could have done to contribute to that vision. We could have built VR headsets. We could have built computer brain connectivity where you jack in like the Matrix and you're part of a virtual world. We weren't, particularly skilled or knowledgeable on how to do those things. But one thing we did look at is something like the Matrix, very dystopian movie. But as a technologist, you say, I wonder what the network looked like. What were the services on a network to allow people and machines to collaborate together in a real-time experience? And we realized was that the internet itself wasn't enough. There needed to be a layer on top of that that made it easy and possible to build software that could bring millions of people together online for various kinds of things. And so that was the mission we set. A vision can be a 50, 100-year vision. A mission is a 5 to 10-year mission. And that's the mission that we've been on. It's providing the best API platform so that developers can create and deliver what we call remote first products. So what is a remote first product? There's a lot of this term remote first is being used by big companies to enable their workforce to work remotely. But for us, remote first is a lot more than that. It's about software products that have been designed from the ground up to assume that the 2, 3, 4 million people that are using that software product are not in the same room together. I'll give you a great example of this. Google Docs versus Photoshop, two content creation platforms. Google Docs, I can go in, I can start typing, and anyone in that document can see me typing, deleting, highlighting, moving things around in real time. Photoshop, amazingly rich platform for image editing, as we all know. And yet, if I want to work with a designer on Photoshop and I'm in a different place, she needs to send me screen snapshots. She needs to share her screen with me. She needs to have me download a 50 gigabyte file with lots of versions in it, right? I can't see that editing happening in real time. And so whereas Google Docs is a great example of a product that was built with a remote first mindset, Photoshop, given how long it's been around, was not. And so we really have existed over the last 10 years and really been growing quickly recently, as you would expect, to allow people to not only build new software that's remote first, but also take existing software products and make them remote first. As a matter of fact, Adobe is a customer, as is Autodesk, and lots of new companies too that in fact, we have over 1,000 customers. Some of them started from the ground up to build remote first products. Some of them took existing products and started to incorporate remote first kinds of experiences. Okay, again, outside of the world of machine learning, but very, very relevant, is this thing called the new economy. And the new economy is a categorization of companies that have all exploded in the last 5 to 6, 7 years, driven over $1 trillion in market value. And this category is now important enough that people like JP Morgan have just spun up an IPO division specifically for the new economy. And if you look at the new economy, it's lots of things. It's food delivery, it's ride share from Uber, it's business collaboration like Slack, it's a whole bunch of things. But if you ask, well, what is one thing tying it all together? It's actually the fact that everything that you do in the new economy apps are things you used to do in a less good way. Right, so food delivery was a little bit more annoying beforehand. Hailing a taxi was painful, right? An exercise bike, it wasn't as great of an experience. So all of these things, all of these new economy companies have actually been driven by this ability to connect everyone remotely through high-speed signaling and messaging, sharing experiences and information in real time, such that when you pick up this device here, you can watch your taxi approaching on the screen. You can see your food delivery order. You can do a money transaction, through payment platform that didn't exist before. And so I think that's, if you can really point to this remote first or real-time connectivity as the one commonality between all of these new economy companies. So when you think about starting a business in a space like this, it really comes down to what's driving humans to do different things, right? And I think there are 3 things that are driving humans. What are the core needs that we're, the itches we're scratching for the new economy? So I would broadly categorize this as our desire to see everything. I want to know when something happens. I want to know where my food delivery order is. I want to know when a car enters a geofence. I want to know when someone is speeding and my child is speeding when they borrowed my car. The second human desire is I want to be everywhere. I don't want to be left out. I want to be at this conference, even though I'm clearly not in a conference center right now. I'm somewhere where there are trees. I actually happen to be in Tahoe. Um, and I want to control everything, right? I want to be able to push a button and watch the submarine explode if I'm James Bond. Or if I'm not James Bond, I may want to let my lights go on, unlock my door lock. In fact, just today, I have some people at my house, many hundreds of miles from here, who needed access to my garage. And thanks to PubNub and some smart home technology, I was able to press a button and open the garage door. So these are the three basic human desires. And we actually now are seeing real world examples of this everywhere, right? We just talked about some of them: location tracking, live inventory, auctions, online cameras, video conferencing, online events. That's a big one now, especially with COVID, right? Having events like this online, smart home products, and I can read the list here, but more and more of our online experience is about these three things. You can fit e-learning underneath here, telehealth, right? All of these things, smart home. And that's kind of what we think about at PubNub as we start enabling companies to build things. So I'm going to jump in a little to like, well, what are the components that do that? What are the building blocks? So um, I don't know how many of you are day-to-day software developers, but if you've ever built software for the web, almost all web software looks very broadly like this. And this is what we call request response or REST type of design patterns. And there's, 20, 25 years of app server development and college training and everything else on how you build applications like this. And that's effectively where your phone, your browser, your laptop, your app needs to get information from a server or the next web page. And what it does is it sends a request, the server does some processing, and then the server returns back some data. And this is the paradigm by which really 25 years of software development has evolved, and security systems around this, right? So this is pretty much how all web-based software, not all, but a lot of it has been designed. But we're actually now moving from that to this. And this is a world where our devices, our servers, our phones, our IoT devices, our houses, they're consuming and emitting little bits of data all the time. Chat messages, IoT signals, temperature readings, you name it. People are moving things on the screen. And so as you think about that move from that request response to this streaming information, a lot of when people talk about data streaming, it's really just funneling data down to a server. So you got, a million IoT devices, you want to funnel that data down and do some machine learning on that information. But the paradigms for remote experiences are not about that design. It's more about devices talking to each other, one to many, many to many, one to one, and servers being aware of that. It's not truly peer to peer. You still have like a server environment that's looking at all of the information going between people, controlling it, and then also um, allowing you to put business rules to say, hey, if this person does these bad things, well, I'm going to lock them out. Or this device does this thing, I'm going to alert someone. So it's this combination of people consuming and receiving data. So that really changes the infrastructure that people need to build software. And that's really where PubNub came in. And we've really done that over the last 10 years by evolving 4 core building blocks. And this actually spreads about 50 APIs, which I won't bore you with, but if you are interested, and I highly encourage you to be interested because I think it's cool stuff and we're growing really fast, you should definitely go to pubnub.com. All of our APIs are available for free online to use. You can sign up, download SDKs, all that good stuff. But what are these 4 building blocks? Well, the core of what we do is a high-speed global messaging system. This is a distributed worldwide, kind of the way a CDN, if you know what someone like an Akamai is. We have data centers all over the world, but it's not for caching data. It's for sending small signals to people back and forth in real time. And what are these messages? What are these signals? Well, they're like everything I said before: chat messages, IoT signals, temperature readings, car locations, you name it. In fact, we've scaled this up so far now that across globally all our data centers, we do about 2 trillion of these signals every month. So there's a lot of these things generating petabytes of data. And it's all with like approximately actually 60 to 70 millisecond latencies between when I send it and when you receive it. Obviously, depending on how far you are from me, there's a speed of light problem. So sometimes it gets up to 150 or 200 milliseconds, but the average is somewhere under 60 milliseconds, I think. And so that's used from everything from multiplayer games to chat applications like Slack types of products and many, many others. Well, signaling back and forth is the core backbone of these kinds of experiences, but there's more that's needed. And the next one I would call, well, we call it presence. Broadly, it's knowing what the state of that user is as that user state changes. So what does that mean? Well, first of all, if you've ever used Skype or Zoom or anything else, you know when the person's online, and as soon as they drop off, it shows you that in some way on the screen. But detecting that if you're building an application, do that's not easy. And so PubNub provides a service called Presence, and it can tell you instantly when a person comes and goes online and offline, and lets you do lots of things around that. But it's more than just online, offline. I can tell you the battery state, the location of the user. If they're in a race, I can tell you how far along they are in that race. I can really associate state change data and then broadcast it out as a user changes their state over time, whether they're typing, if you see a typing indicator, things like that. So the third building block here is on-the-fly logic. So we call this PubNub functions. Again, it's made up of a set of APIs and features, but what does it actually provide? Well, if you are sending messages all over the world, 2 trillion per month, like we are, you generally often want to put some business logic in between the person sending the message or the device sending the message and the person receiving it. Some obvious examples, you may want to strip out obscenities if it's a chat application. But if it's an IoT application, you may want to do some pattern detection, right? This is where things like machine learning come in. You might say, I only want to alert a person if temperature changes more than 5 minutes in the next hour, or if these patterns start to emerge, right? Sometimes it's very, very mundane, simple things. Sometimes it's more complex. But either way, you often want to put business logic in between the publishers and their subscribers of this data. And if you don't have the ability to take your business logic and push it up into the network, the only other way you can design your application is you're streaming all of this data down to your servers, running this business logic and pushing it back out into the network. And that simply doesn't scale effectively. It's a lot of work for each customer. And so by allowing them to push their business logic to the edge of our network, it allows these kinds of things. And then finally, as all this data is flying in around the world in between people and devices and servers and everything else, you often want to route, aggregate, enrich that data, transform it through third-party APIs. And there's this amazing ecosystem these days of services on the internet, not least of which many, many machine learning services that allow you to do things like pattern recognition for content and a whole bunch of other things, but not just machine learning, right? You may want to trigger an email, an SMS message. There's lots of things you may want to do. And so by tying these 4 core building blocks together, PubNub over the last 10 years has provided and evolved this effectively a platform for building these remote first applications. And as you can imagine, we extend into lots of places. We have over 1,000 customers, everything from powering fueling and tracking the locations of fueling trucks at over 100 airports worldwide, including Heathrow and Dubai, to some of the most popular chat applications, dating apps, games, telehealth, e-commerce. It's really a broad swath of remote first applications. It's actually amazing. Sometimes, I was shocked when we found out we were powering fueling at Heathrow. Like, oh, we didn't know it was going to happen. So we've really evolved very quickly in a lot of different areas. And so, I won't go too deep into these things, but messaging, provides a lot of functionality for a lot of these kinds. Oops, let me go back there. A lot of these kinds of paradigms and these kind of use cases, I should say. And we've learned over the years that when you're trying to create a high-speed signaling system between, well, I guess today we connect to over 300 million devices every month. You tend to have lots of patterns you see, one-to-one doctor-patient chat, 1 to 20 million when we powered the IPL in India for the cricket league there, where you're broadcasting game information and sentiment out to 20 million people. You have many-to-many, like in game information. And so we provide all of these interesting ways of multiplexing data down, of broadcasting it out, of filtering data on the fly in our servers so people can only get information they're interested in from channels. A whole bunch of design patterns. And this core messaging system has really been the foundation of where we started. And then we talked about the user state presence. So I won't bore you with all of these things, but you can imagine it's not just knowing someone's online, but are they typing? How many people are in a particular room? We take this for granted in Zoom. I can look right now and see how many people are watching. But if you're trying to build an application that provides a similar experience and you don't want to have the infrastructure team that someone like a Zoom has or a WebEx, PubNub provides you a very cost-effective and scalable way to do that. We talked about the on-the-fly business logic, right? So here you've got so many examples of where people want to stick business logic in the middle. Actually, language translation is becoming increasingly important for customer support apps. So you can imagine now where as someone is chatting, you may want to have the information translated on the fly. In fact, we have one big customer in India has millions of active users. And as you know, in India, they don't have just one language. There's many different languages in India, Tamil and Hindi, and of course English, they speak there as well. But there's a number of languages. And so their support team doesn't necessarily speak every language in India, but that can now use on the fly, even within a single country, language translation to support a very large population of customers. But there's many other things too. One of the funniest examples, I guess I can't use the name, but we had a very large, very famous global software drink manufacturer use us during a Super Bowl experience that they had built. And they wanted to keep it authentic. So they didn't actually want to strip out any obscenities or anything else. They wanted to let people say what they wanted. But there was one word they refused to have in their chat streams from all these millions of people. And that was the word of their competitive software company. Soft drink company, I should say. Sorry. So one soft drink company and the other soft drink company did not want to see that brand in their thing. So just that alone, simple, funny example, but it actually turned into millions and millions and millions of executions of logic per minute as messages came in to strip out any brand offensive words. So I thought that was a funny, simplistic but high scale use of why you would want this in a streaming environment. And then finally, API ecosystem. So, making phones buzz, doing analytics, obviously MLAI, which I'll talk about in a bit. Lots of mapping, where's my food order? Where's my taxi? Text to speech. So text to speech is important again in a food delivery environment where someone's riding on their motorcycle with a food order on their back, and someone needs to they need to hear a change in a dispatch request or an address change. They're not going to be riding their moped and scrolling on their mobile. They're going to be getting a text to speech conversion so they can hear it right into their ears. And then so as PubNub provided these core services, we have, like I said, over 50 APIs. We realized that to really start to attack a broader set of potential customers, we've been really working on making it easier. So rather than just saying, hey, everyone, here's our 50 APIs and some documents for how to use them, we now provide these out-of-the-box frameworks, chat, many flavors of chat, from millions of users at a concert to one-to-one doctor-patient secure chat with HIPAA compliant, real-time mapping frameworks, device control frameworks, really making it easier for people to drop in these kinds of features. And in terms of machine learning, more and more customers have been leveraging both the integrations we've already built or using our functions, business logic layer to add in their own. Some of these brands you're probably familiar with, obviously IBM Watson, some of the smaller ones like MonkeyLearn, Alception, the kinds of things they're doing. Well, I mentioned some of these, language translation, sentiment analysis is becoming really more widely used, especially in customer support use cases. Just more general pattern identification, being able to upload the models you trained on static data, on large historical data sets, and then apply those models in the streaming environment by just plugging them into our functions layer. Image detection and object detection within those images. A lot of chatbots. So in customer support, again, I keep using that as an example, but there's others. There's a dramatic cost savings if you can get the number of support conversations answered by a robot as opposed to a person. And I think some of our customers are now pushing 80% chatbot success, where only 20% of the support requests are actually being escalated to a human being. And then, as you can imagine, when you're dealing with any kind of remote experience, especially with an unknown audience, content moderation becomes key. And so, being able to score content, understand its offensiveness rating, but in other things as well, and being able then to block it or to route it separately or to alert on it is a key use. And these are just a few examples of what you can do when you've got 2 trillion messages coming through our system every month, and the kinds of use cases that people see. This here is just a snapshot of the I think it's 1 hour of traffic patterns taken during midday in the US of where devices are actually accessing. I think it's 1 pixel per device accessing PubNub through some application. We're embedded in everything from Yelp to DocuSign to Peloton itself to Swiggy, which is a massively large food delivery company in India, and Zomato, just tons of, like I said, over 1,000 customers. And obviously the hotspots change during time of day. But what's interesting about this is we're also building up a really, really large corpus of data on latencies, because one of the pieces of metadata that we're sending back and forth here is also we're sending back and forth latency data and understanding how long it's taking requests and success rates for messages to go back and forth. And we're able now to measure and look for pattern recognition on ISPs and which ISPs are having problems and what times of day that's happening. So we actually just filed a patent on, just received a provisional on this whole weather sort of forecasting of internet latencies based on just this metadata, which is just a happy accident of the usage of our platform. So again, with the corpus of data that's being created now in real time, a lot of it's being lost, right? A lot of this data is transient. It happens on the fly, locations of devices and things like that. It's not all being captured. And so we, for us, the privacy of our customers' data is paramount. We actually allow them to decrypt it so we can't even see it. But we're also providing more opportunities for customers to archive, for us to archive on their behalf, for providing hooks and metadata they can wrap their encrypted data with for future analysis, and doing the best we can to capture this data so we can train models in a lot of really interesting ways. I mean, I think we are storing some huge number of petabytes a month now, and that's just stuff we can store, and that's just stuff that's logged. And then that, we purge some of that, obviously. So we, for all of the privacy and reasons that we have with our customers and agreements we have, but even the stuff we can store is now in massive. And so we're really looking at what we can do with this corpus and how we can make sense of it, and what value that's provided there. So with that, I will end. I did threaten to show my just because these conferences can get boring, so I did threaten to show my deep fake of myself as Dolly Parton in a 1980s music video, because I figured, hey, if everyone's doing machine learning, I should probably learn about deepfakes myself. So I did one, but I saw people recoil in horror when I actually suggested I might do that. So I'll probably hold off. But I noticed there's some questions that were posted here. So I'll address those too, and of course people can jump in. So I'm going to stop sharing here, and I did not make good on my threat to show the Dolly Parton deep fake, but maybe if there's some bribe going on. Okay, so just a question to the moderator, Cloris. Should I just jump into the questions that are posted here on the Zoom, or what's the best thing to do here?
Yeah, we do receive a lot of many questions for you, Todd. So one of our audience named Young asked, like, software API platform for developers sounds like new industry to me. So how many players are there now, and what's the position of PubNub?
Great question. Well, we're very fortunate to be in a very, very frothy environment right now from an investment and a capitalization perspective. It's software API platforms for developers is really growing very quickly. And funnily enough, we raised our first round of financing in the year 2012. And when we did, it was a lot of faith-based investing. What I mean is I waved my arms around and talk about how the world was going to look in a few years, and investors said, well, you sound like you're convincing, so we'll give you some money. But you got to think back then, there was, except for World of Warcraft and maybe WebEx, Zoom didn't exist, and WeChat and WhatsApp and Face, I mean, any of these things existed. Uber didn't exist, and so almost all this whole new economy wasn't there. And so API platforms doing these kinds of things were definitely early. But now, it takes me 5 minutes to list our customers and what we do for them. And it's not just us. So if you look at a company like Twilio, they were kind of the first API company to go public a couple of years ago, maybe 3 years ago now, and they're now at a $43 billion market cap. A company that just does video streaming, so you can build sort of a Zoom experience, called Agora, just went public 3 months ago, and they're now a $5 billion company. And so, we're really riding these nice tailwinds of the more broad recognition of investors, and both public and private, what the best that was said to me last week by a large investor was, the world is becoming a software company. And so there's a recognition that API companies like PubNub are sort of like an index fund for that new economy, because you can invest in one of those companies and hopefully it pops. But if you invest in a company like PubNub, you're pretty much, it's like an index fund where we have over 1,000 new economy customers. And so this whole idea of software API platforms has been gone from a sort of aspirational thing when we started the company to, I think, what I heard last week, it's the fastest. If you invested in enterprise infrastructure type of company in the last 5 years, in aggregate, they've had the highest return of any other investment that you could have made over the last 5 years. So there's a lot of excitement in this broad space.
Yeah, and I know you are a winner for like a few API awards, right?
Yeah, I mean, yes, we've won lots of awards, everything from, WebRTC signal awards, which is funny because we actually don't do WebRTC signaling, but we do signaling that helps WebRTC to, I mean, over the 8 years we've been around, as an invested, funded company. I don't, but yes, lots of different types of awards around. I think we just won this year, Best API Platform Award from the API World, if I remember correctly. But I think more
Great.
broadly, yeah, just to finish that up, I won't. But I think more broadly, software development today is different than it was 10 years ago. Today, software development is like building with Legos. And so the simpler you can make your Legos, so that, and because software developers are under huge pressure, time to market, and the easier you can drop in pieces of componentry that fit together and let you, focus on the UI, the skin of it. But the API layer is something you can just sort of, farm out to companies like PubNub. Sort of is the way that that the world seems to be going.
Thanks. So another question from our audience called Nate Hammett. He or she asked, can your API monitor oxygen and temperature from a variable health monitor to check if someone is affected by COVID-19?
Yeah, the cool thing about PubNub is we're agnostic to the data that gets sent through our network. So it's meant to be structured data, right? So we have actually a number of healthcare companies that have built IoT devices on PubNub, such that the data is actually capturing that, and then not just capturing the data, but triggering alerts and everything else based on what's coming through the network. So rather than taking that data all the way back to servers and getting calculated, we can actually capture it at the edge of the network as it gets consumed, do some processing and decide whether it's relevant to pass that information on. So absolutely, if you've got products like this, again, we don't actually provide the wearable health monitor, but if there's one that you've got, then it's a very low cost, high scale way of just hooking it into a PubNub. In fact, an employee of PubNub, I think he has a blog post on this, where his daughter was born with type 1 diabetes, and he was able to connect PubNub to her monitor so that he and his wife could monitor her glucose levels throughout the day and get alerts. And so, his top of his laptop used to have a readout all the time where he could be very close and monitor in real time.
And we have another two questions from Megan. Megan seems really interested in real-time machine learning. So she asked, the machine learning is offline. How to do the real-time machine learning? What is the challenge? Is there any use case for the real-time machine learning in your system, like e-commerce?
Yeah, it's a good question. So, I mean, machine learning, it's you build the model, right? And then you train the model, and you can always improve the model, but then it's operating on real-time data. It's funny, I was talking to an oil and gas company a year or two ago, and they had done an amazing job building a very, very sophisticated model around predictive analysis in the oil and gas industry. I wish I could speak more intelligently to what the model was doing, but I don't remember. Probably they didn't tell me. But they had done they had a huge corpus of data that they had built the model on. But then they said, okay, but here's the problem. These oil and gas companies aren't interested in running the model against historical data. It's not very useful. What they want to do is run the model on the data now being generated in real time. And they said, what we don't have is a globally distributed set of data centers that can consume this data and run this model. And we were like, well, it's like a marriage made in heaven, because that's what we have. And we have this PubNub functions layer, which would allow us to easily plug in, say, for example, a TensorFlow model into it. And the nice thing about models, as you guys probably know better than I do, is training the model takes a massive amount of compute power, but operating the model is very lightweight. And so being able to do that on a message by message or collection of messages basis or signals basis is actually pretty lightweight from a CPU perspective. And so I think that the challenge I often see in the world of machine learning is like, cool, we've got all these great historical corpuses of data, corpi of data, but what do we do with respect to this massively distributed nature where people and machines are? And I think that's where we've been slowly working to bridge, that we've got the distributed system. So how do we bridge that into the machine learning models that have already been built?
Thanks for your answer. So another great topics you just raised is like data security, data scalability, and data reliability. So can you expand on those topics?
Sorry,
Maybe
I'm
PubNub
just looking at the
realize
question
those.
here. Which question was it, Cloris? I don't actually see. What was the question again?
Yeah, can you expand on how PubNub maintain and develop or improve data security, scalability, and
Oh,
reliability?
a good, a good question. Well, three separate questions. Uh, so we've always reliability has been a key part of PubNub, and so we've always offered a 5 nines service, meaning that we give credits if we're down for more than 26 seconds a month, and if you multiply 99.99% with the number of minutes in a month. Um, and that also speaks to scalability. So how do we do that? Well, we've always realized when we started the company, other people were trying to do this sort of data streaming stuff by having servers, in a data center. And we said, this is more about a distributed systems problem. And so we filed and were awarded patents and built a whole system around um, linking together data centers around the world, so that if someone's in Frankfurt, Tokyo, Mumbai, San Francisco, as they launch the exact same app, the developers who wrote that app don't even have to think about it. They just write the app. But when the PubNub part gets activated, the user connects to the global data center closest to them. So, 4 of us could be in 4 different parts of the world. We'll all be connected to 4 different data centers. And then we start sending data back and forth to each other. And PubNub does all the smarts around saying, okay, I'm going to route Todd to San Francisco and Cloris to Frankfurt and whatever, whoever where people are. And then do the smarts around figuring out how do we replicate that piece of data to which data center. And the nice thing about that is it also has this reliability aspect. So if a data center fails, we flip over automatically to the next data center and everything's cached for you there. So people who are in California can just flip to Virginia and so on. So there's a lot of failover. That deals with sort of scalability and reliability. And by the way, we now operate thousands of servers, I think tens of thousands of cores worldwide for doing these kinds of things. Security is obviously a big topic, and it splits into 3 areas: data encryption, access control, and who has access to the data streams themselves, and then regulatory security like GDPR, HIPAA, PCI, SOC 2 compliance. There's a ton of various kinds of compliance. I won't spend too much time on any of them because it's all available to learn on our website. We can talk to you more, but broadly, provide different kinds of both point-to-point and end-to-end encryption of the data, such that if you want us to do more acting on the data, you can do point-to-point encryption and put your logic in the middle. If you want to do end-to-end encryption, we don't get to see the data, but you can still hang metadata around that so we can route appropriately and even aggregate and filter. So there's a lot of cool things we do on the encryption side. On the access control side, that's the most important piece, I think, frankly. It's basically, we have a very fine-grained access control layer, so you can literally give effectively read-write access or publish subscribe access and some other permissions to groups of devices, to any individual device, a whole host of features that can be flipped on automatically, so you don't have to think about it, or ones that you can sort of build in gradually. And that's allowed us to do things like HIPAA compliance and others, which is why we power so much telehealth these days, and med devices and things like that. And then from regulatory compliance, we got all the logos on our website, which has been very time-consuming, expensive, and it's really changed the whole nature of our company for being a SOC 2. We actually literally bring auditors in once a year that go through our entire system and make sure that we are compliant with all the tenets of SOC 2, as an example. Same goes for HIPAA. We certify there, and a number of other certifications. So there's a big story there, but obviously longer than you probably have patience for.
Thanks. So another question from Heyman. He asked, so are you hosted on AWS or GCP, like cloud provider, or edge compute?
Great question. Well, all of the above. We moved between different data center providers over the years. PubNub is a completely software-based solution, so it can sit anywhere that we can have general compute. I think in the early days we were more on GCP. We moved to AWS. We've been in SoftLayer at different points. We moved different data centers around, and then just most recently we actually pushed PubNub out to the edge, so that use Verizon's data center. Is actually pretty cool because in a beta right now, what's neat about PubNub is if you build your applications on PubNub, you're automatically 5G ready because now our stuff's getting out to the edge, and as people start adopting 5G, you get to take advantage of the reduced latency, which, by the way, you don't get in a request response app, because no matter how close you are to the edge or how 5G-ish and fast your connection is, you still have to get all the way to the server, processed, and come back. So so the answer is kind of all of the above.
Another question from our attendee, Ferus, asked, what advice would you give to data scientists? Not sure if it's your area.
I'm probably the most qualified person to give advice to anyone, as I sort of become more zen in my experiences in the world, but especially data scientists. But I would say that it's a really good question. Um, I think it, obviously depends on what you're trying to accomplish. But as I said at the beginning, when you look at the explosion of value that's being created, and especially in emerging markets and emerging economies, it's because of billions of people who are getting online for the first time in industries that literally didn't exist, like the fact that this company Ant, spin-off from Alipay, Alibaba, is going public, I think this year, or sometime soon, I don't know. But they now have generating, I think, more payment transactions per day than Visa and MasterCard combined. And I don't think they existed 10 years ago, right? And so all of these things are massive amounts of data driven by billions of people who didn't exist in the online world 5 to 10 years ago. And I think this is the most exciting thing from a data science perspective, actually, because I mean, why do you think governments are pushing people to online payment platforms? They're also very excited from a data science perspective to understand what's going on in their populations. And sometimes that sounds nefarious, but there's also lots of altruistic, amazing, world-changing kinds of things we can use to drive a data-based decision making around um, economic policy, around social policy. And so I know there's so much good corporate data science around looking at data lakes and trying to find patterns for companies to become more profitable. That's awesome. I think that the value of data science to social and economic, um, global and nationwide policies is going to be really interesting, exciting. And so the more you can, get access to those streams of data and provide value, I think it gets really exciting.
Thanks, Todd. We have two more questions. Yeah. So one is from Mengxi. She asked, since data center and its related operation performance and operation performance a major source to back up your business, will the capacity of the network sense be a problem in PubNub's expanded future?
No, I don't think so. The nice thing is that those things you talked about, storage, processing, bandwidth, is for all of the fears that the people are going to move faster, or the demands are going to move faster than the technology. That just hasn't come true. I don't know if you remember, there was a famous, in the United States at least, there was a senator who was from Alaska, not a very technical person, who would argue we got to have more legislation because the tubes are going to get clogged, and it didn't happen. There's been lots of prognostication around storage costs or processing costs, and in fact, it's the exact opposite. So actually, the storage costs are coming down faster than the speed of, or processing costs and the speed of adoption. I think for us, actually, the hardest challenge for us is innovating fast enough to make sure we're taking advantage of the new lower cost processing and things that are out there. So so I actually think that's the good news. I'm sure there's more prognosticators out there saying we're about to hit some wall, but I've heard that many times before, and we tend to always find solutions. I think hardware people tend to move faster than software people to adopt the new hardware.
Maybe the last question from Roy. Roy asked, what challenges do you foresee in cybersecurity in the world of big data and the cloud?
Yeah, that's a good question. I think we're all a little scared. We talked about in this presentation how fortunate we were that COVID happened. COVID happened when we actually had access to all this technology in low cost ways, so that people around the world could go online and do things. But it has an equal threat that so much of our life is now based online. So I think the challenges are really clear. There's obviously national security challenges with well publicized attacks between governments. I would call that the new Cold War, right? I think there is obviously corporate security. I mean, there's obviously a trillion-dollar industry, maybe not trillion, but many hundreds of billions of dollars of companies out there that are providing software for and hardware and network solutions for cybersecurity. But I do think having friends in the intelligence services, also in the United States, that who have explained, there's just, I think it is the Wild West still, and I think we could probably all of us in this conference list out the myriad of cybersecurity challenges, and I think it's probably the biggest risk to everything we've been talking about. And I don't unfortunately think there's an easy answer to it, other than a constant battle between attack and defense that'll go on for this foreseeable future.
Got it. Thank you for all the wonderful questions and thoughts. Thank you for answering all of these questions with your informative knowledge sharing and sharing your great platform and cutting edge technology. So any other questions? If not, then we will wait for the next session.
Well, thanks to everyone. I really appreciate it. And I didn't even get a chance to show my deepfake, so we'll have to do that next time.
Yeah, yes, please. You can do it now.
No, that's okay. but that's all right. But thank you, guys. I really appreciate the time. Thank you, Clarice.
Thank you, Todd. Have a nice day.
You too. Bye-bye, guys.